Take a look at this. It's our proper proportion giant atom model of science. Now, this part isn't very giant. That's because it's just the nucleus, the middle of an atom. Now, in here are two kinds of particles, protons and neutrons. No one knows what they would really look like. The protons have a positive electrical charge, like a spark. And the neutrons have no charge. They're neutral. They just hang out in the nucleus. Now, buzzing around the outside of the nucleus are very small particles called electrons. Maybe you've heard of them. In fact, the flow of electrons from one atom to another is called electricity. If this vibrating, buzzing ball is the nucleus of an atom, how far away do you think the electron would be? Well, as far as you could jump? No. As far as you could throw a ball? As far as you could run? Well, yeah. Take a look. You can see it from here. It's way out there. The electron would be here. 500 meters. 5 soccer fields from the nucleus. So, everything that's made of atoms, everything that you can touch and feel, is mostly empty space. Empty space. Empty space. Empty space! Now, the electron weighs, a 10,000th of those particles in the middle. And it's going around so fast that it's only here now and then. It's here, and then here, and then I gotta go.
All right, ladies and gentlemen, we're going to be quickly talking about the building blocks of matter, which is made up of atoms. You should have a paper, your Cornell notes that looks like this. Sorry, it's sideways, but let's go ahead and get rolling. All right, so first of your essential questions is, what is matter? And to the right, it says that matter is anything that has mass and takes up, that first blank for you guys is going to be space. So anything and everything around you that you can pretty much touch is going to have matter in it. The desk, the stool that you're sitting in, all that wonderful stuff. So according to Bill Nye, he answered the question for you, what is an atom? It's the smallest possible unit, into which matter can be divided while still maintaining its properties. So everything is made up of atoms. Everything around you, you're made up of atoms. Everything that you pretty much can touch is made up of atoms. All right, let's go ahead and answer our next question. What are protons? Well, if we played Simon Says at the beginning, you already know what the charge of a proton is. It is a positive charge. It has a mass. He said weight, but really in science we collect items' masses. So it has a mass of 1 AMU, and then it is located in the nucleus. I underlined the things that you should have written inside your Cornell notes. The next thing is, what is a neutron? Well, neutrons are also inside the nucleus. They're neutral. They have no charge. They have a mass of 1 AMU. AMU, again, stands for atomic mass unit, and they are also located in the nucleus. So your protons are these red ones, and your neutrons are the blue ones. All right, your next question asks you, what are your electrons? Well, your electrons are these guys right here. Bill Nye said they're spinning around the nucleus. They have a negative charge. They have a mass of 1 over 1,836 AMUs, and they're located in the electron cloud. And a lot of times you'll hear me abbreviate it the E- cloud. Okay, and you're going to need to start remembering the rule of 288. So when it comes to electrons, they live in rings. So this is ring number 1, and this is ring number 2. In the first ring, you can only fit 2 electrons. In the second and third rings, you can only fit up to 8. So when you hear that, you need to be thinking of the rule of 288. and those are your blanks. So up to 2 in the first ring, up to 8 in the second, and 8 in the third. You can use the periodic table of elements in order to figure out how many protons, neutrons, and electrons you have. And so at the bottom, you can see a picture of an ape, and it says ape man. But really, I want us to concentrate on this section. I really want you to pay attention here, guys. This here is called the atomic number. It tells you 2 of the particles automatically. It tells you the protons, which I'll abbreviate P+, and it tells you the electrons, E-. And so whatever that atomic number is, that's the number of protons and electrons you have. So both of these are going to be 15. Then your neutrons is really simple. It's a little bit of math. This is the atomic mass that you need to figure out your neutrons. So it's 30.97. So I want to look at the number just to the right of the decimal. That number is going to tell me whether or not I need to round up 1 or keep that number the same, because I have to round first. So 30.9 rounds to 31. So I'm going to have 31 here, minus my atomic number of 15, and I end up with 16 neutrons. Basic math, really simple. Don't worry, we're going to practice this quite a bit. All right, lastly, on the last section, you see something that says ape man. So this is our little memory tool for how to remember how to find the protons, neutrons, and electrons in an atom. So the A is going to be our atomic number. Make sure you're filling this in, and you can abbreviate. Then your P, I bet you guys know, stands for protons. E is going to be your electrons. And M is going to be your mass. And you always want to remember to round that mass. Round it first. A again is atomic number. Sorry for the clicking noise. And your N is going to be your neutrons. Okay? And the way I wrote it out, just basic up here, basically tells you how to find the information. So A equals P equals E. That means the atomic number, the proton number, and the electrons are exactly the same. So if it was 6, all 3 of those things would be 6. Your man is your mass number minus your atomic number, gives you the number of neutrons. And guys, that's pretty much it. So make sure you read the board if you are in class with me, or you have finished answering any questions at the bottom of your Cornell notes. And ta-ta.